Okay, today we're looking at an introduction to inverse functions. You've heard the word inverse before. We're looking at inverse functions. Now, you have heard the word inverse before when solving equations. Okay, so with algebra, we've looked at inverse operations. For example, what's the opposite of multiplying? Dividing. So, for example, if I've got the function, so I'm going to call f of x the normal function. If I've got y equals 2x, so that's the normal function, I'm just going to show you the inverse function. The way we write the inverse function, it's got special notation. It's written as function to the -1 of x. Now, that is not 1 over the function of x. I'll show you in a minute when we graph it what it is. So, actually, what I'll do, I'll write here normal function. Wait a sec, I'm going to rub that off. And the inverse function. Normal function is written as function of x. If my first normal function is y equals 2x, my inverse function is, so this means y equals 2 times x or x times 2. What's the opposite of x times 2? Or what's the inverse operation of times 2? Divide by 2. So the inverse function is y equals x divided by 2, okay? So I could write here that, for example, I could write, well, my function in x is 2x, but my inverse function in x would be x divided by 2, okay? Yes. Working out the inverse function, I will show you a very quick method later, but just for our first 5 minutes introduction, we're just going to say we have to start with the x and what's happened to the x. It's x times 2. So the opposite or the inverse operation of timesing by 2 is dividing by 2. Now I'm going to put these on Desmos. I'm going to graph y equals 2x. I'm going to graph y equals x on 2 on Desmos, and you're going to see the relationship between them. I'm in Desmos. Beautiful maths, it's called, free beautiful maths. Y equals 2x is my first graph, straight line. That's the red one. My inverse function is y equals x divided by 2, the blue graph. And now I'm going to draw the line in another colour. I don't want it blue, that's the only thing. I want the line y equals x as well drawn. I'm just putting y equals x, good, it's green. Now, girls, let's look at some points on the red curve. So, is that big enough? Do you want it bigger? Yeah. I'll just click here. Whoa, and I'll move it. Okay. All right, is that... No, that'll do. So I'm clicking on y equals 2x. See this point here? Can you... Oh, the numbers need to be bigger. Girls, this is the point 1, 2 here, okay, on the red curve. And this, the curve, this is the line y equals x, and the blue curve, I've just sat on it now, I've highlighted it, that's the curve y equals x on 2. Okay, so, yeah, this is the curve y equals x on 2. See the green line? Give me the relationship between these two curves and the green line. Symmetrical, yeah, it's been what? This line, the red one's been reflected in the line y equals x. So this is my original function, y equals 2x. This is my inverse function, y equals x on 2. And they have been reflected in the line y equals x. Thing that I want to point out, I'm here sitting on the blue curve, and the point that I'm on here is, say, up here, that's the point 2, 1. Now, that corresponds, if I reflect that in the line y equals x, I end up here at the point 1, 2. Notice this point here is 2, 1. If I reflect this point in the line, I end up at the point 1, 2. Okay? Just leave that for now. We're going to look at another curve. Okay? So what we've got, original function in red, inverse function in blue. We've noticed that they are... One function is the reflection of the other one in the line y equals x. We're going to look at it. I'm going to look just some simple functions to start with. Y equals x plus 5. Actually, no, not plus 5. Let's just make it x plus 2, otherwise it just gets 2. So that's my normal function. So my function in x, my normal function is x plus 2. So what's my inverse function, girls? Instead of, so what happened to the x? It's x plus 2. Opposite of plus 2? Inverse function will be x minus 2. So inverse function, writing it in the correct notation. So from now on, I don't want to do them like that. I'm going to write function of x is x plus 2. Inverse function is x minus 2. I'm going to graph both those, and we're going to see if one function is the reflection of the other function in the line y equals x. Can you think of what they're both? Tell me about the gradient of both those lines. And one cuts the x-axis at? The first graph cuts the y-axis, at, and the other one, and one's just shifted down from the other, and the line y equals x will be in the middle. So I'll put that back up in a sec. I'm going to go to Desmos again. Got it? So we've got y equals x plus 2, y equals x minus 2. That one's not working. Y equals x minus 2. I'm hoping you can see it because it's in yellow. I need to make this. Okay. And I'm going to put the line y equals x in between them. Okay. There's y equals x plus 2, purple. There's y equals x minus 2, the inverse function, and I'm now sitting on y equals x. Can you see that one line is just the reflection of the other line in the x-axis? Okay? Right, we're going to look at some more functions. We're going to look at y equals x cubed. I'm going to write it on the sheet in a minute. Anyone know what the inverse, what's the opposite of cubing? Cube rooting. Now, I can't do cube root on this, but that's the same as x to the power of what? No? A third. Nearly. You're on the right track. So cube root. So if y equals x cubed is my original function, the inverse function of cubing is cube rooting. So I'll go, which is the cubed root of x, but I can't find it here, so I'll just go x to the power of a third. Okay. And I'll make that bigger. And I'm going to draw the line y equals x. Hopefully it's green. And it is. So, can you see? So the cubed root is the red function. No, the cube function. Y equals x cubed is the red function. Can you see it? Y equals x to the cube root of x is the inverse function, because it's the opposite operation of cubing, is cube rooting. And look at the green line. If you reflect the blue into the green line, you'll get the red curve. And if you reflect the red curve into the green line, you'll get the blue curve. So if I just draw one function for you, you can draw the inverse by drawing the line y equals x and reflecting it in that line. Okay? So inverse functions and normal functions are related because they're just, one of them is the reflection of the other function in the line y equals. Okay, girls, now, you remember I said that there was going to be an easier way? Someone said, how do you know if y equals 2x is the function, that y equals x divided by 2 is the inverse, and that it's not 2 divided by x? What we do, the easiest way to find an inverse is to take your original function, like this one, y equals x cubed, and what you do, where there's a y, you put an x, and where there's an x, you put a y. So let me just make this all bigger. Okay, that's better. So girls, what I'm going to do, the red function is y equals x cubed. I'm going to graph x equals y cubed. Now that is the inverse function. What did it just sit on top of? It just sat on top of the blue one. Look, I'll get rid of it. Look. So there's y equals x to the third, the blue one. I'm now going to do x equals y cubed. So I've got, sorry girls, I need to, all right. I've got y equals x cubed, but to find the inverse, you just swap the x and the y. So x equals y cubed, you'll notice, is just the same as y equals x to the power of a third. Because if you take y equals x cubed, x equals y cubed, and make y the subject, don't you cube root both sides? And you get y equals x to the third, or the cubed root of x. So the inverse function, y equals x cubed, its inverse is y equals the cubed root of x, or it's the same as saying x equals y cubed, where you're just swapping x and y values. Now, this swapping x and y values is really important. I'll show you why. Let's look at any point, for example, on the blue curve. So I can get rid of that one now. All right, let's look at this point here this is about 1 point, I think it's 1.25 or something. This point here where my cursor is. Can you see it? Now, I should be able to find the same, so 2, 1.2, roughly. So on the red curve, I should see that in the opposite way, 1.22. You know how you're swapping y and x? Well, on the inverse function, the y and x values are swapped as well. So on the blue curve, I've got 2, 1.2. Actually, you know what point we'd find really nice and easy is 8, 2. Do you know why? Because 2 cubed is 8. Okay, so I might do that. Actually, no, it's too hard to see. Oh no, I can still see it. Look, down here. There it is. Look at the blue curve. What have I got here? Oh no, I just had it. But I saw the 8. There we go. Wait. Right, there we go. 8, 2 on the blue curve. Look at the red curve. What's this point? 2, 8. Okay, so when you've got y equals x cubed, and I said you can swap the x's and the y, x equals y cubed, well, the x and the y values swapped, which means the domain of one curve is the range of the other. The range of the first curve is the domain of the other. And they're the concepts that I'm now going to go through. Okay, so main things are that inverse functions are reflections of the normal function in the line y equals x. We've noticed that for the normal function and the inverse, the x and y values are swapped around. Okay, we've also noticed that the easiest way to find the inverse function is to swap the x and the y values. Okay? Okay, that's what we're going to do. So I'm just going to pause that and we'll do our theory now. One more example. The one that we looked at on the graph, if y equals x cubed, so I'll say if my function of x is x cubed, then my inverse function, that's how I write it, f to the minus 1 of x, will be x to the 1/3, or the opposite of cubing is cubed root of x. So we looked at that on our graph. Now, let's say you might find some functions really hard to find their inverse. Like I might say to you, so let's do some notes. So to find the inverse function of a function, this is what we do. Just replace. So to find the inverse function, you might want to put f to the minus 1 of x of an ordinary function of x. All you do is replace the x value, the x with a y and the y with an x, and then make y the subject of the formula. Okay, so to find the inverse function, f to the minus 1x of a function of x, we replace the x with y and the y with x. We swap them around basically, and then make y the subject of the formula. So, example, find the inverse functions of the following. Going to do some hard ones now, not too hard. Y equals 2x plus 5. I want to see if someone can guess. What you've got to do, you've got to start without rearranging. Don't rearrange yet. But what's the story of the x? What happens to the x here? X, what happened to it? Times 2 plus 5. Undo it backwards. X times 2 plus 5. Undo it from the back. No. What happened to x times 2 plus 5? What's the last thing I said was plus 5? Minus 5, divide by 2. Don't do it like that, Bart. But let's see what we get. So that's the normal function. So now I'm going to go inverse function. So that's my normal function. Inverse function is x equals 2y plus 5. Of course, we're not going to try and work it out like I just did with you. We're not going to do that. What we're going to do is simply replace the y with the x and the x with the y and make y the subject. So what do I do now? X minus 5 is 2y. Therefore, y equals what? X minus 5 divided by 2, which is what we had just said. All right, let's look at another one. If your original function is x cubed minus 4, what's your inverse function? Sorry, I should put y equals, but it doesn't matter. If your original function is that, in other words, y equals x cubed minus 4, what's my inverse function? So to find your inverse, just replace your, now sometimes if they give you function of x equals that, replace your function of x with y. We always know y is function of x. Now what do I do for my inverse? So this is my inverse function. So therefore, f to the minus 1 of x for that first one is, that's my inverse function. Got it? That's my original function up there. So here's my original function, y equals x cubed minus 4. Can anyone tell me what they think the inverse would be without, what's the story of the x? What happened to the x? X was cubed and then take away 4, undo it backwards. X plus 4 cube root. That's what we're looking for. So let's just do it, not guessing like that, but how do we do it? Replace y with the x and make y the subject. What do you get? X plus 4 is y cubed. So therefore y is the cubed root of x plus 4. Okay, so that's how you find the inverse function. Really simple. Replace y with x and make y the subject. So therefore, and the notation for inverse function is f to the minus 1 of x. Now, that is not the same, all right, you got that? So, inverse is not reciprocal, okay? Inverse is not reciprocal. F to the minus 1 of x does not equal 1 over the function of x. It is not that. This is this means inverse function of x. This means, this whole thing means the reciprocal of function of x. So they are different. So f to the minus 1 of x does not mean 1 over function of x. What does 1 over function of x mean? They're almost the same, but they're written differently. Well, let's say I give you 1 over x cubed. How do you write that? As a negative index. Isn't that x to the negative third? So how do I write this? Function of x to the negative 1. So this is the reciprocal of function of x. Got it? It's different to the inverse function. So that's a not equal to sign there. Okay, 1 over fx is fx to the negative 1. Remember, negative power means 1 over. So they are not the same. Okay, you can see where the negative 1 is here. It's inverse of function of x. Okay, that's really important as well. So just a little heading, graphs of functions and their inverse. You already know this, how to graph. If I give you the graph of a function and ask you to graph its inverse. So, actually girls, you know how this is called inverse functions? Sometimes when we graph the inverse, it's not always a function. So I'm going to go back to Desmos in a minute and show that to you, okay? So, you probably don't remember, but at the beginning of year 11, sets of ordered pairs, like 0, 1 and other ordered pairs, and you join them together, and when you make a curve, we call them a relation. We don't always call them a function. Do you remember what the function, yeah, remember if something is a function if it passes the vertical line test. So what we're going to do, we're going to talk about that in a minute. So graphs of functions and their inverse. So the graph of, now at the moment I'm just going to call it an inverse relation, not a function, because all inverse relations are not necessarily functions. Graph of the inverse relation, I'm going to call it a relation at the moment because it's not always a function, is obtained. So the graph of the inverse relation is obtained by reflecting your graph, by reflecting the original graph in the line, I'll call it in the diagonal line, y equals x. So we're going to draw some. Look, I've got 3 blue pens on my desk. No red, no nothing else. So let's do, what am I going to draw? Oh, I might just draw this one. Bit hard. Wait, I know you can't see it. One sec. I need another colour. So, graphs of functions and their inverse. So the graph of the inverse, we're just going to put relation at the moment. Sometimes it will be a function, sometimes it won't. Is obtained by reflecting the original graph in the diagonal line y equals x. Function is in blue, and the line y equals x is in black. It's not in black, it's in red.
It's not green.
Give me any other colour. All right, I've got purple. Black. I've got black. Do you know how to draw the inverse function? What am I going to do? So I'm just going to call this function of x is the blue one. The line y equals x is red. Do you know how to draw the inverse? Reflect. I can fold the paper. Let's say I folded the paper on the red line. Wouldn't this end up down here? Actually, can I have the green, please? Okay. So the if I folded the page where it's red, the inverse would look like this. Okay? Can you see? You got the idea? All right, now. Okay. I'm going to draw something else in a minute. Got the idea? So inverse function is the green one. So can you write on the green curve f to the minus 1 of x? Now, I'm going to do this another way just by plotting some points. I don't even care what the function is, okay? So I'm going to do another one. Had you already written the notes? All right. So I'm going to put this quite clearly, my points. So let's, I want you to label the axes 1, 2, 3, 4, 5. And the negatives as well. Okay, so I'm going to draw some function here. I don't know how it's going to look. I'm just going to make it up. So I'm going to draw my line. I'm going to draw my original function. Let's say it passes through the point 1, 2. And then it's going to pass through the point 2, 4. Oh, that's a straight line. Can we make it 2, 5? 2, 5. Okay. So it's going to pass, so get rid of the 2, 4. It's going to pass through the point 1, 2. So I've got the original function here. Function of x passes through 1, 2. It passes through 2, 5. It's like a sort of parabola type thing. I'm also going to get it to pass through negative 1, negative 2. And I'm going to get it to pass through negative 2, negative 5. It's like a cubic, but not quite, all right? So that's my original function. It's passing through 1, 2, 2, 5, negative 1, negative 2, and negative 2, negative 5. Do you remember what I said about functions and their inverses and x's and y values before? What? They're swapped. So let's say you didn't even know what that function is, and I don't know what it is either. Well, the inverse function, girls, you just swap. So to draw the inverse function, even if you don't know what this function is, you just swap the x and y values of each point, of each coordinate, and draw. And then we'll draw the line y equals x when we're done and see if we think it's a reflection. I mean, yes, this is going to be a reflection in the line y equals x. We know that. But to make it accurate, you need accuracy when you're drawing an inverse function. What you'll do, inverse function, what's the opposite of 1, 2? 2, 1. Not negative 2, negative 1, just 2, 1. All right, 5, 2, 5 will be now the point 5, 2 in the inverse function. Just swapping the x and y values.
So if the negative was on 1, can you do anything?
No, all right, yeah, I will. Oh, this curve doesn't. Well, if I had negative 2, 1, it would be 1, negative 2. You're just purely swapping the points over. So negative 2, negative 1. No, negative 1, negative 2 will be negative 2, negative 1. And negative 2, negative 5 will be negative 5, negative 2. Now I'm going to plot those points. 2, 1, 5, 2. Can you see if I do the dotted line, y equals x, see how it's the mirror image? If I folded this, girls, that would sit on top of the red. All right, I'll keep going with this dotted line. But that is the easiest way to draw the inverse, girls. And you're going to need accuracy. And so my other points are negative 2, negative 1. Oopsie, in red. And negative 5, negative 2. So there's my negative 2, negative 1. It looks like this. The red one. Sorry. Okay? Can you see? If I actually folded in that dotted line y equals x, the blue would sit on top of the red. It would. Okay? How do you make it accurate? If you're asked to draw an inverse function and you know points on the original graph, just swap them over. Got it? If you're not accurate, you're going to lose a mark. There's only 70 marks in the extension 1 paper. You don't want to lose 1 mark because you couldn't be bothered swapping the values around. Got it? No, you got time. It's worth the mark. I know it's a hard thing, but yeah. All right? So if for example, it's 1, 2, you know you're going to show the point 2, 1 in your inverse function. If definitely the point 2, 5 is in your original graph, make sure you show 5, 2 in the other one. Got the idea? All right. Are all inverse functions, no, inverse relations, functions? Question mark. Are all inverse relations functions? We're going to consider y equals x squared. You can give me some points on this curve if you want. 1, 1's one of them, and 2, 4. Okay. And I'm going to go, give me some other points over here. So I've got, consider the graph y equals x squared, that function. So consider the function y equals x squared. Some points on it are 1, 1 and 2, 4. Can I have this point here, negative 1 what? Negative 1, 1 and negative 2, 4. So what I'm going to do now, we're going to do exactly what we did before. We're going to draw the inverse relation by swapping x and y values, because that's the easiest and most accurate way to do it. Okay, now.
Do we still keep the y-axis called y?
Yeah. Yep. So instead of the point 1, 1, we still have 1, 1, don't we? 1, 1 is 1, 1, no matter which way you draw it. 2, 4 on this graph, the original graph, is what? 4, 2, roughly here. So I've got 1, 1, I've got 4, 2 on my inverse. I'll call this my inverse relation. We're not sure if it's a function yet. Now, what happens to negative 1, 1 becomes what? This one's for you, Georgia. So 1, 1 becomes 1, 1. 2, 4. So here's my original function. I've got 1, 1. I've got 2, 4. I've got negative 1, 1. This is what you were asking before. And negative 2, 4. So on my inverse, I've got 1, 1, 4, 2. What have I got now? 1, negative 1. Just swap them. And 4, negative 2. Let's draw those. 1, negative 1. 1, negative 1 down here. And 4, negative 2 down here. Now, that's an inverse relation, but that is not a function. Why? So, what we do is, so we need to write the inverse relation is not a function. So the inverse relation is not a function because it does not pass the vertical line test. Now, instead of going to all the trouble of drawing the inverse relation and then deciding, isn't it easier to look at the original function, and if the original function passes not the vertical line test but the horizontal line test, so if the original function does not pass a horizontal line test, the inverse relation will not pass the vertical line test. Okay, so instead of drawing the original function, drawing the inverse relation and then deciding, what we do is, so if the original function does not pass a horizontal line test, then the inverse function will not pass the vertical line test. So if the original function does not pass the horizontal line test, then the inverse function or inverse relation will not pass the vertical line test. So if the original function does not pass the horizontal line test, HLT, fail. Vertical line test, fail. Doesn't pass it, not a function. So if the original function does not pass the horizontal line test, then the inverse relation will not pass the vertical line test. Therefore, the inverse relation will not be a function. The inverse relation will not be a function. Okay, now we're going to look back at that in a minute. This is the curve y equals x squared, isn't it? So if I wanted to find the inverse function, inverse relation, it's there. It's not a function because it doesn't pass the vertical line test. So if my y equals function of x, and that's, no it's not. If my function in x is y equals x squared, then my inverse function, f to the minus 1x, don't we replace x with y and y with x? And if I want to make y the subject, how do I do that? Plus or minus the square root of x. Please, whenever you're square rooting, you need to take plus or minus the square root. Now, in other words, I've got two functions here, so I've got positive square root of x and I've got negative root x. I've basically got two functions here. And if I look at what I drew before, my inverse looked like this. One of them, this bit is y is positive root x, and this bit down here is y equals the negative root of x. Now, if I take my original y equals x squared curve and just draw part of it. So what I'm going to do, I'm going to take my original y equals x squared curve, I'm going to put them in two different colours, and yes, this whole curve is y equals x squared, but I just want to look at, for the first bit, in the blue bit, I just want to go from x greater than or equal to 0. Now, if I disregard the red bit, does this pass the horizontal line test?
Yes.
So tell me which of those two relates to this blue bit. Just think of drawing the line y equals x and reflecting. Is it y equals positive root x or negative root x? That's the match for the blue bit. If I drew a dotted line here and I reflected it, it would go like this. See this and that? I'll call them number 1. They match. That matches with that. Let's say I'm looking at the curve y equals x squared for values of x less than or equal to 0. Okay? All right, I need this bigger. So the inverse, this blue bit has an inverse function, just the blue bit for x. So if I consider y equals x squared for x greater than or equal to 0 only, it has an inverse function. That goes with that. All right, I might just get rid of this and draw it on another graph. If I look at the red bit only, so if I look at y equals x squared for x less than or equal to 0 and disregard the rest, that passes the horizontal line test. So therefore the inverse will pass the vertical line test. If I do a dotted line of y equals x, it will come out like this. Not quite like that. I haven't drawn that very well, have I? I'd have to go like negative 2. Let me just draw it properly. Negative 2, 4, 4, negative 2 down here. That's its inverse. Got it? See how I was going to draw it over here wrong? So if that's going to happen and I know the curve, negative 1, 1, negative 2, 4, 1, negative 1, 4, negative 2 to make sure you're drawing it right. So the red bit is y equals negative root x. It's the inverse of the left-hand side of the y equals x squared curve. You got it? Now, actually, how can I write... So this is y equals x squared for x greater than or equal to 0, does have an inverse function. So curve 1, y equals x squared for x greater than or equal to 0 only if I restrict the domain. This has an inverse function. All right? Only that bit. Also, on its own, the red bit, y equals x squared for x less than or equal to 0, also has an inverse function. Okay? Now, what's the inverse function of the blue bit? It's y equals positive square root of x. And the inverse function for the red bit is y equals negative root x. Do you get that idea? So if something doesn't pass the horizontal line test, you can just say, yep, I'm going to consider that function, but just for these values. So y equals x squared for x greater than or equal to 0 will have an inverse function. And y equals x squared for x less than or equal to 0, only considering that, will also have an inverse function. Okay. Look, I think that's enough today, because tomorrow I'm going to look at the domain. Actually, you might be able to tell me. I've just got no room. Do you know what the domain for this blue bit is? I'm just going to put it here if I can fit. What's the domain and what's the range for the blue bit? Domain is, yeah, there's the domain, x greater than or equal to 0, no, it's x greater than or equal to 0. What's the range for this function? Y is greater than or equal to 0. Actually, it's not going to work here. All right. For the red one, what's the domain? X less than or equal to 0. What's the range? Same. Y is greater than or equal to 0, girls. For the red curve, the original function, x is negative, y values are positive. Now, are you okay with that? For the blue function over here, x is positive, y is always positive. Got it? For the red function here, x is negative values, y is positive values. Now, you know how I said x's and y's are swapped? If I look at the blue function, just tell me the domain and range of the blue function over here of the inverse. So the inverse function here, what's the domain of that? Tell me about x values.
Is it the same thing?
Yep, it's the same. And the range is the same, but this one's not. Tell me for this inverse here about the domain. Tell me about the x's. Are they positive or negative?
They're positive.
X's are positive,
The y is negative.
y's are negative. Now that's an opposite of the original function. Look at the original function. The domain x is negative. Happens to be the range, but you swap it for y. Y is negative here. With the original function, y is positive, and the domain of the original function, x is positive. Because the x becomes the y, and the y becomes the x. You know, to find an inverse function, we swap. But we'll be doing more of that tomorrow. Okay? So tomorrow, we're going to look at domain and ranges of functions and inverse functions. All right? But that's just a quick, they're the main ideas. All right? Swap x with y, make y the subject, reflection in the line y equals x. It'll only have an inverse if it passes the horizontal line test. Basically, the domain of one becomes the range of the other, but I need to spend more time on that. Okay? But you've got a good overview there, and we'll do some more tomorrow and some more examples tomorrow.